Hello everyone. Good afternoon to all. How are you all? Oh, it's evening now, huh? Good evening. Um, let's wait 1 more minute. Let all of them join. Hello everyone. Good afternoon to all. How are you? How are you all? Okay, so it's time to start. I hope everything is good. Okay. My voice is clear to all of you guys, and also my screen is visible clearly to all. So let's start the class. We are continuing the topic or chapter. Name is sequences and series, right? Okay. So in the previous classes, we have completed arithmetic progression, geometric progression, and also we have completed harmonic progressions, right? And also we have completed arithmetic mean, geometric mean, and harmonic mean, right? And also we have solved so many previous questions also, right? In the last class also we have solved. Okay. So so what we are going to in this do in this class, first we'll discuss the homework questions, right? In each every class, first we are discussing the first homework questions. So how many of you tried these questions and got the answers? Can you please write your answer in the chat box? YouTube guys also, you can write your answer in the chat box also. And then hello ZNB KNR, hello, how are you all? आगे तुम लोग ठीक है बहुत ZNB KNR, that means ZNB Kunur, right? Yeah, I got it today. It's name. Okay, ठीक है. So how many of you solved this question and got the answer? Anyone got the answer of this question? Anyone? Yeah. Oh, sorry, Karimnagar. I'm sorry. Absolutely. I'm sorry. Extremely sorry. Okay, that's ZNB Karimnagar. That's a nice name. Thank you all. Thanks for your response. Okay. So how many of you tried this question and got the answer? Can you please respond in the chat box? I gave this question as your homework, na? You must have tried this one. Yeah. Okay. So after this question, we'll go through how we can insert n arithmetic mean in between two numbers. If two numbers are given to you, then how can you insert n number of arithmetic mean, n number of geometric mean, and also n number of harmonic mean? How can you insert all this? And we'll solve some previous year questions with them, and then we'll go through the most important thing, that is arithmetic geometric progression, right? Arithmetic geometric progression finally we'll see, and we'll complete this chapter today only. Okay, from the next week we'll start another topic, that is I most probably will start complex number. Okay, so let's start the solution of this question. Let's solve. Okay, in the last class I told you some result, hai na? Some inequality I told you, na? What is the relation between, what is the relationship between arithmetic mean, geometric mean, and harmonic mean? Can you say in the chat box? All of you know, na? Arithmetic mean is less than equal to geometric mean is less than equal to harmonic mean. Is it or not? Yes. So by using this concept only, we'll solve this question. Okay, got it? So think about it. How can you use this concept to solve this question? Okay, let's solve. So so to find arithmetic mean or geometric mean or harmonic mean, Okay, here we are getting three inequality. Either arithmetic mean is less than equal to geometric mean, it's one inequality, or geometric mean is less than equal to harmonic mean, another inequality, and also another inequality we are getting arithmetic mean is less than equal to harmonic mean. So three inequalities we are getting here. So which we can use here? So सबसे अच्छा है the most common or famous inequality, that is arithmetic mean and geometric mean, to solve such type of equation, right? So let's solve. Yeah, the answer is D. JNB Karimnagar is saying the answer is D. Let's see what is the answer. Okay. चलो ठीक है. So what it is given? A, B, C are positive real number and A plus B plus C is given as 18. Okay. And you need to find the maximum value of A square, B cube, C4. So remember, when in sequence and series, maximum and minimum value and range is coming na, you must have in your mind that you should use this inequality to solve the question. Is that clear? Okay. So what are the terms I should choose? What are the terms I should choose to apply this inequality? This is important. Okay. So let's see, if I'll choose A by 2, B by 3, B by 3, B by 3, and C by 4, C by 4, C by 4, C by 4. These are my 9 terms I am choosing. Okay. So for these 9 terms, now I am going to apply the inequality arithmetic mean is less than equal to geometric mean. Now apply it. So if I'll apply it, so what will happen? So see, A by 2. So arithmetic mean will be A by 2 plus A by 2 plus B by 3 plus B by 3 plus B by 3 plus C by 4 plus C by 4 plus C by 4 plus C by 4. Okay, divided by 9. Is it or not? Which is greater than equal to, can I write what if they are the 9 terms? So what is the geometric mean will be? Now A by 2 into A by 2, which is A square by 4 into B by cube, B by 3 into B by 3 into B by 3 is B cube by 27, right? And C by 4 to the power 4, that is C to the power 4 divided by 4 to the power 4 is 4 4 just 16, 4 just 64, 256, right? Okay, whole to the power 1 by 9. Is it or not? Yes or no? Tell me. Now you can easily solve this one. So same. So you can say, sir, why we are choosing this one? Because we need to find A square, the value of A square, B cube, C to the power 4, right? See, in the numerator, what you are having? In the numerator, what you are having? A by 2 plus A by 2, that is 2A2 by 2 is A. Similarly, if I'll take the LCM for the B by 3, then it will be 3B by 3, that is B, and 4C by 4, that is C. So that is in the numerator we are having A plus B plus C by 9, right? A plus B plus C by 9. Is it or not? So in the left hand side, what we are getting, A plus B plus C, by 9 is greater than equal to A square by 4, B cube by 27, and C to the power 4 by 256 whole to the power 1 by 9. Is it or not? Yes or no? So in the question it is given that A plus B plus C is 18. So 18 by 9 is greater than equal to A cube, B cube, A square B cube, C to the power 4 by 4 into 27 into 256 whole to the power 1 by 9, right? So in the right and left hand side, it becomes 2, right? So I am writing here, instead of 18 by 9, I'm just writing it is 2. So if I'll take 9 power, if I'll take exponent 9 on both sides, what will happen? So left hand side becomes 2 raised to 9 is greater than equal to, this becomes 2a square b cube c to the power 4 upon 4 into 27 into 256. Is it or not? Is it or not? Right? So, okay. So now can you cross multiply both the sides and you will get the answer, right? So it will be a square b cube c to the power 4 will be greater than equal to, what will happen? Acha, this can be written as this can be written as चलो पहले तो राइट हैंड साइड को हम ऐसे उसको सिंप्लीफाई करके लिख देते हैं. So that is equal to a square b cube c to the power 4 divided by 4 is 2 square and 27 is 3 cube and 256 is actually 4 to the power 4. So 4 to the power 4, that is 4 to the power 4. 4 is 2 to the power 2. So 2 to the power 8, right? So this becomes, right hand side becomes, which is equal to a square b cube c to the power 4 whole divided by 2 to the power 10 into 3 to the power 3. Is it or not? Okay. Now if we'll multiply or if we'll divide or if we'll multiply this, cross multiply it, what we'll get? We'll get a square b cube c to the power 4 is less than equal to 2 to the power 9 into 2 to the power 10, that is 2 to the power 19 into c to the power 3. So this is the answer. So what is the maximum value? What is the maximum value of a square b cube c to the power 4? That is 2 to the power 19 into c cube. So what is the answer? 2 to the power 19 into 3 to the power 3. Yes, sorry, that is 3 to the power 3 na. So the correct answer is option D. Very good, JNB Karimnagar, your answer is absolutely correct and the correct answer is option D. Very good. Clear? I hope this is clear to all of you guys. Understood? YouTube guys, you can respond in the chat box if it is clear to all. If you have any doubt, you can ask also. Right? Is it clear or not? Shall I move to the next thing? Yeah. Clear hai na? Guys, please be interactive. Please. I'm waiting for your response. Who is sitting with the computer or laptop with the pen or tab? Okay. So let's move to the next thing. Now, how we can insert a number of arithmetic mean in between two numbers, right? So if you have two numbers, suppose you are given two numbers. Suppose I'm taking A and B are two numbers, and I'm asking to insert an arithmetic mean in between these two numbers A and B, right? So how can you insert? Suppose I'm taking those arithmetic means are A1, A2, A3 up to AN. Okay. So now after inserting these arithmetic means in between A and B, so what is the sequence you are getting? So that will be in arithmetic progression. Yes or no? Clear? Yes or no? हाँ कि ना? हाँ. So if अरे कोई भी दो नंबर अगर तुम्हारे पास है, सपोज आई एम टेकिंग 2 and 3, So 2 and 4, I'm taking 2 and 4. If I'll ask you to insert two arithmetic mean in between these two numbers, so what you will do? What we will do? So that means simply one. If I'll ask you to find to insert one arithmetic mean, then to simply you can do 2 plus 4 by 2. That is 6 upon 2, which is 3. So 3. So then you can see the resultant sequence is in AP or not? Yes, it is in AP. It is in AP. So similarly, if you are inserting n number of arithmetic means in between two numbers A and B, they will be also in AP. If they are in AP, so total number, how many total number of numbers, terms you are having in this AP? Anyone can say how many number of terms you are getting in this arithmetic progression? The number of terms will be n plus 2 number of terms. Is it or not? N plus 2 number of terms you are getting here, right? Is that clear? With the first term, what is the first term here? Now first term is A. Okay, first term is A. Remember, first term is A. And what is A1? A1 is the second term. And what is the last term? Last term is B. Right? Last term is B. So what is the common ratio? Sorry, common difference. What is the common difference here? How can you find the common difference here? Okay, if the last term is B, so we can say the number of terms, the total number of term is n plus 2. So what is the number? What is the order of the last number? So this will be, the last term will be an plus 2. Yes or no? So an plus 2 will be my B. So by using the formula, an plus 2 will be, the first term is A plus n plus 2 number of terms minus 1 into D is equal to B. Yes or no? So similarly, we can say here A plus n plus 2 minus 1 is n plus 1 into D is equal to B. So from here we can get easily the common difference, that is D is equal to B minus A upon n plus 1. So this is the formula, remember, this is the formula to find the common difference. Okay, this is the formula to find the common difference. Is it clear to everyone, guys? Yes? Yes or no? है ना? So you have the first term, okay, and you have the common difference. Now you can find all the n number of arithmetic mean or not. Yes or no? So similarly, you can find by using this formula, you can find the common difference, right? And you have the first term. Then what will be A1? A1 is the second term, right? A1 is the second term, na? A1 is the second term. That is A1 will be, A1 will be A plus D. Yes or no? So A plus D, in place of D you can write here. So A2 will be A plus 2D. A3 will be A plus 3D. So similarly, AN will be A plus ND, right? A plus ND. So likewise, you can find all the arithmetic mean in between two numbers if you are given. Is it clear to everyone? Simple, na? Is it clear to everyone, guys? Remember, one important thing, total number of terms is n plus 2, and to find the formula to find the common difference is D is equal to last term minus first term upon number of terms minus 1 or n plus 1. Okay, D is equal to B minus A upon n plus 1. And to find the arithmetic mean, what is the formula? N is equal to A plus ND. A plus ND. Is that clear to everyone, guys? Clear? Shall I move to the next thing? JNB Karimnagar. Clear hai na? Make notes with me. Make notes with me also. Okay. Clear? Done. Chalo. Okay. Now this is all about your arithmetic mean. Now we'll move through geometric mean. How can you insert n number of geometric mean in between two numbers if you are given? Clear? So how can you insert, guys? Likewise, in arithmetic mean we did. Similarly, we can do the same similar process we can follow for the geometric mean also. Suppose here you are having two numbers A, B, right? And you need to insert, थोड़ा नीचे लिख देते हैं, A, B, and you need to insert a number of geometric mean in between these two numbers. Suppose I am taking here n number of geometric means are G1, G2, G3 up to Gn. Okay, so G1, G2, G3, Gn are my n number of geometric mean. Is it clear? Then the resulting sequence will be in geometric progression. If it is geometric progression with the first term is A. And what is the common ratio here? What is the common ratio? How can you find the common ratio? And total number of term is? Total number of term is n plus 2. Yes or no? So what is the common ratio? How can you find the common ratio? That is, if I'll ask you to find the an plus 2, the last term, an plus 2 is b. It is given already. An plus 2 is b. Yes or no? So if an plus 2 is equal to b, then to find an plus 2, what is the formula? What is the formula to find an plus 2? So common ratio will be, if suppose and let the common ratio is r, right? So it will be a into r to the power n plus 2 minus 1 is equal to b. Is it or not? So a into r to the power n plus 1 is equal to b. Is it or not? So r to the power n plus 1 is equal to b upon a. Yes or no? So from here, if we'll take n plus 1th root on both sides, then r is equal to b upon a to the power 1 by n plus 1. So this is the formula to find the common ratio. Okay. Remember, this is the formula to find the common ratio when you are asking to find the geometric mean, to insert n geometric mean in between two numbers a and b. Clear? Done? Is it done or not? Yes. So r is equal to b upon a whole to the power 1 upon n plus 1. So similarly, so tell me now, what is G1 here? So G1 will be, G1 is the second term. So G1 will be AR. So G2 will be AR square. So similarly, Gn will be AR to the power n. Remember, Gn will be AR to the power n. Clear everyone? Yes? Clear or not? Done. So this is the way to insert n number of geometric mean in between two numbers when it is given. Okay, is that clear to everyone, guys? Is that clear to everyone? Similarly, now we'll proceed to, now we'll move through the harmonic mean, or how we can insert n number of harmonic mean in between two numbers if it is given. Suppose here in this case also, if you are given two numbers a, b, and you need to insert n number of harmonic mean in between these two numbers h1, h2, h3, H4 up to Hn, right? Okay, so then the resulting sequence will be in harmonic progression. Yes or no? If it is in harmonic progression, then their reciprocal will be in arithmetic progression. That means we can say 1 upon A, 1 upon H1, 1 upon H2, 1 upon H3 up to 1 upon B will be in arithmetic progression. So after getting this sequence, we can say these 1 upon H1, 1 upon H2, 1 upon H3 up to 1 upon Hn are n arithmetic mean in between 1 upon A and 1 upon B. So total number of terms is n plus 2, right? Total number of terms is n plus 2, right? So now we can use the concept of arithmetic mean and we can solve the questions, or we can insert the n number of harmonic means in between two numbers. So this is all about your concept, how we can insert n number of arithmetic mean, n number of geometric mean, and n number of harmonic mean. So remember, the important thing is to find the common difference in case of arithmetic mean is equal to D is equal to last term minus first term upon n plus 1. And in the second case, R, the common ratio is in case of geometric mean, when you are inserting n number of geometric mean in between two numbers A and B, then the common ratio will be B upon A, the last term upon first term whole to the power 1 upon n plus 1. Clear everyone? Okay. So similarly, in case of harmonic mean, what we can do, we just need to take the reciprocal of A, H1, H2 up to Hn, B, then the resulting sequence will be in arithmetic progression, and now we can use the formula to find the common difference. D is equal to 1 upon B minus 1 upon A upon n plus 1. From here you are getting the common difference, and the first term will be 1 upon A, right? The first term will be 1 upon A. Then you can find all the harmonic means you have inserted in between A and B. Is that clear to everyone? I hope this is clear to all of you guys. Let's move to the next thing. ये हो गया. This is the question based on the previous concept. So how can you find? Okay, this is a very important questions also, which came in 2022 JEE mains. Actually, it was a top question, I can say. So if you'll go through the actual procedure to solve these questions, so it will be lengthy, more lengthy. So what we'll do, we'll learn one shortcut with it also, and also we'll see how we can solve by the actual method. So in the question it is given that if n arithmetic means are inserted between A and B, A and 100, okay, so there are two numbers given, one is A, another one last number is 100, and you need to insert n arithmetic means, that is A1, A2 up to An, okay, such that the ratio of the first mean to the last mean is 1:7. That is, it is given that A1 upon An is equal to 1 upon 7, 1:7, and also it is given that A plus n is equal to 33, right? So how we can solve this question? So by using the given information, we can solve this question. So let's start with this only, right? So let's solve. A1 upon An, it is given that 1 upon 7. So we can write this as A1 can be written as A plus D, because this is the second term. Suppose the common difference is D, so A plus D, and An will be, An is the previous term of the last term, right? Previous term of the last term. That is, we can write this as 100 minus D. Yes or no? 100 minus D, which is given as 1 upon 7. And also it is given that A plus n is equal to 33. So from here we can get n is equal to 33 minus a, or a is equal to 33 minus n, right? So likewise we'll use, no need to worry. Chalo, okay. So if we'll cross multiply this, what we are getting, see here, 7a plus 7d is equal to 100 minus d, right? 100 minus d. And also suppose this is my equation 1, okay, and also the last term is given as 100. So 100 is the an plus 2. Yes, an plus 2, that is a plus n plus 1, n plus 1, sorry, n plus 2 minus 1 into d. So which is equal to a plus n plus 1 into d, right? So in place of n, we can write from here, we can write n is equal to 33 minus a, right? So in place of n, we can write 33 minus a plus 1 into d. Yes or no, we can write or not, right? So in place of d also we can write, in place of d also we can write this. From here we can conclude 8d is equal to 100 minus 7a, right? So d is 100 minus 7a upon 8. So from here we are getting the value of d, right? So chalo, let's substitute it. A plus 33 minus a plus 1 into d, that is 100 minus 7a upon 8. So now you can see all the terms are in a. Okay, so if we'll cross multiply, this is equal to 100. If we'll simplify this, we'll get an quadratic equation. I'm directly writing the quadratic equations because we have less time. I'm writing by solving this equation, we'll get one quadratic equation, that is actually 7a square minus 330a plus 2600 is equal to 0. So by solving here, by solving this quadratic equation, you will get the value of a as 10 and 260, 10 and 260 upon 7. Okay, 10 and 260 upon 7. So if we'll, now you are getting the value of a as 10 and another value we are getting, that is 260 upon 7. So if we'll check one by one, if you are first, if we'll put a is equal to 10 here, if we'll put a is equal to 10 here, then you will find the value of n from here. After finding the value of n, we can find from here also d. Then you will need to check whether a1 upon an gives you 1 by 7 or not. So this is actually a lengthy method to solve this question. So if we'll go by this way, we'll get the question, or you will get the answer in a long time. So what we'll do, we'll follow a very shortcut method, that is the method of elimination. We'll go through the solutions by option wise. So what we'll do, let's see. So how we can solve it? Suppose we have the number a and 100, and we have n number of arithmetic mean we have inserted in between these two numbers, a1, a2 up to an. Okay, so now d, I am getting d is equal to last term minus first term upon, common ratio is last term minus first term upon n plus 1. So this is my d, right? And also it is given a plus n is equal to 33. Is it or not? Now if d is equal to this, d is equal to this, so in place of n also we can write 100 minus a upon n is equal to 33 minus a. So 33 minus a plus 1, that is we can write 34 minus a. So d, I am getting here, d is equal to 100 minus a upon 34 minus a. Now also another information it is given, that is a1 upon a7, sorry, a1 upon an which is equal to 1 upon 7. Now, if we'll use the formula, so this will be a plus d upon a plus d. Directly we can write, na? That is a plus d. Okay, sorry. A plus d upon 100 minus d, which is equal to 1 upon 7. Now, if we simplify or cross multiply, what you are getting? 7a plus 7d is equal to 100 minus d we are getting here, right? So, by simplifying here also we are getting 7a plus 8d is equal to 100, right or not? 7a plus 8d is equal to 100 we are getting, right? So, d is equal to 100 minus a upon 34 minus a we are getting. Okay. Now, ठीक है, चलो. If we are getting this equation 7a plus 8d is equal to 100, so if we'll choose or if we'll gone through option wise, if we'll go through option wise and solve the question, then what we can do? So if we'll put n is equal to 23, okay, option dekho, option, go to the option. We need to find the value of n here. It is asking to find the value of n here. Okay. So if we'll go through n, if we'll put n is equal to 21, n is equal to 23, n is equal to 22, n is equal to 24, right? In place of d, or here in this equation, if we'll put n is equal to option wise, if we'll go through, then I am putting I'm directly go to the answer. You can check it one by one. I am putting n is equal to 23. So if n is equal to 23, then a becomes 33 minus 23, which is 10. So I'm getting, by taking n is equal to 23, I'm getting a is equal to 10, right? So let n is equal to 23 and I'm getting a is equal to 10. Is it or not? Yes. So now check whether it is satisfying or not. So 7a, now check from here. By putting the value of a, 7 into a is 10 plus 8 into d. Oh, d, we don't have d na. So d we can find na here. From here we can find the d. So d will be, d is equal to 100 minus 10 upon 34 minus 10. So 100 minus 10 is 90 minus 20, 90 upon 24, which is equal to 15 by 4. Yeah. So it is 15 by 4. So D I am getting 15 by 4. So now check 8 into 15 by 4. Whether check it is giving you 100 or not. 7 into 10 is 70 plus this is 2. So 30. Yes, it is giving you 100. So the correct answer is, the value of n is 23, right? The correct option for the answer, given answer is 23. So option C is the correct one. Option C is correct one. Is it clear to everyone, guys? Clear? Chalo. If it is clear to all, let's move to the next question or next concept, that is arithmetic geometric progression, right? Arithmetic geometric progression. So what is it actually? We know what is arithmetic progression. We know what is geometric progression, right? So now we'll learn what is AGP, right? What is AGP? Oh, someone is raising the hands. Let me check. Okay. Chalo, ठीक है. So what is AGP? AGP is actually combination of arithmetic progression. We can say combination of arithmetic progression and geometric progression, right? Combination of arithmetic progression and geometric progression. We can take another one example, like I can say 1 upon 3, 2 upon 3 square, 3 upon 3 to the power 3, 4 upon 3 to the power 4, and so on. So you can see here all the numerators are in arithmetic progression and all the denominators are in geometric progression. So all the numerators are in arithmetic progression and all the new denominators are in geometric progression. So that's why it is called an AGP or arithmetic geometric progression. So how we can find the nth term of this AGP? You can find directly. So we can write this as summation. If we'll add this, so what will be the nth term or summation? R is equal to 1 to n. For the numerator, we can substitute it as by the first term is 1 plus n minus 1 into d upon a into a is 3 into r to the power, r is 3 to the power n minus 1, right? So this will be, yes, so this will be the sum, or we can say this is the nth term. First we will find the nth term. Let's see, this is my nth term, Tn. This is my Tn. Okay, the sum will be likewise, sum को हम ऐसे represent कर सकते हैं, r is equal to 1 to n ar upon 2 to the power r. Okay, ar upon 2 to the power r. So ar is the terms of arithmetic progression and this is my sum of geometric progression, 2 to the power r. Okay, chalo, ठीक है. So this is actually one example of arithmetic geometric progression. Let's solve one question here. First question. Okay, so this is the first question. How can we solve? If it is given that s is equal to, I'm writing it again because very small fonts are using here. S is equal to 2 plus 6 upon 7 plus 12 upon 7 square plus 20 upon 7 to the power 3, 30 upon 7 to the power 4, and so on. So you need to find the value of 4s. You need to find 4s, right? So how can we solve this question, guys? Okay, you can see here in the denominator we are having one GP, right? In the denominator we are having an GP. And also in the numerator also 6 plus 2 plus 4 is 6. 6 plus 6 is 12. 12 plus 20 is 12 plus 8 is 20. 20 plus 10 is 30, right? So see, you can observe here 2 plus 4, 6 plus 6, 12 plus 8, 20 plus 10. Okay, and in the denominator also we are having one GP with the common ratio 1 by 7, right? With the common ratio 1 by 7. So this is the type 1 arithmetic progression, type 1 problem, arithmetic progression. How can we solve it? You need to learn the method, how we can solve it, right? So we have written the S here, right? We have written the S here. What I'm doing, I'm suggesting to write 1 upon 7 into S below the given series and shifting one terms forward. Okay, shifting one terms forward. So okay, so that means how we can write when I am multiplying 1 by 7 on both sides of the given series. So first multiply 1 upon 7 with 2 and write here. That is 2 upon 7. Okay, one step forward. Plus, when I will multiply 1 by 7 with 6 by 7, it will be giving you 6 upon 7 square. This will give you 12 upon 7 cube. This will give you 20 upon 7 to the power 4 and so on. Right. Now, I am suggesting to subtract s upon 7 from s. Subtract the second series from the first series. Okay. So what you will get? It will subtract what we are getting. See, let's see. So we are getting s minus s by 7, that is s minus s by 7, that is 6s upon 7, which is equal to, यहाँ पे तो ये क्या हो जाएगा 2 plus 6 by 7 minus 2 by 7, that is 4 by 7 plus 12 by 7 square minus 6 by 7 square, that is 6 by 7 square plus 20 by 7 cube minus 12 by 7 cube, that is 8 by 7 cube, and this is 10 by 7 to the power 4 and so on. Now we can see in the numerator what you are getting in the new series. In the numerator you can observe you are getting one arithmetic progression. Yes or no? In the numerator you are getting an arithmetic progression. Is it or not? And also in the denominator you are getting the same geometric progression. Similarly, again I am suggesting to multiply 1 upon s with 6x upon 7, 1 upon 7 with 6s upon 7, that is 1 upon 7. If you multiply, this will give you 6s upon 7 square, and write all when you are multiplying 1 by 7 on both sides, write in the right hand sides by stepping forward one step. Okay. So when I will multiply 1 by 7 with 2, it will give you 2 by 7. I'm using the other color. 2 by 7 plus 4 by 7 square. Yes or no? Plus 6 by 7 cube plus 8 by 7 to the power 4 and so on. Now subtract again. Now again subtract. By again subtracting, what are you getting? 6x minus 6s by 7 minus 6s by 7 minus 6x minus 7 square is equal to 2 plus 2 by 7 plus 2 by 7 square plus 2 by 7 cube plus 2 by 7 to the power 4 and so on. Okay. So you can observe here in the right hand side, you are getting one geometric progression. Yes or no? In the right hand side, you are getting one geometric progression. Is it or not? So easily we can find the sum of geometric progression. And also you can see in the right hand side, if you have an infinite geometric progression. So what is the formula to find the sum of infinite geometric progression? S infinity, that is a upon 1 minus r. This is the formula to find the sum of an infinite geometric progression. So this will be here. The sum will be the sum of the right hand side will be, the first term is 2. The first term is 2 upon 1 minus r is 2 by 7 upon 7, 2 by 7 upon 2, that is 1 by 7. So which is 2 upon 7 minus 6 upon 7, which is 14 upon 6, that is equal 7 upon 3. Okay, so 7 upon 3. And in the left hand side, what we are having? In the left hand side, we are having, if you take the LCM, that will be 7 square, this will be 42s minus 6s is equal to 7 upon 3. That is 42 minus 6 is 42. कितना हो जाएगा भाई, जल्दी बोल दो. So what is the answer? 42 minus 6 is 36. 36s by 7 square is equal to 7 by 3. And you can easily solve it. 36s into 3 is equal to 7 cube. And s is equal to 7 cube by 3 into 36. Okay. So the correct answer will be 343 by 108. This is the correct answer. 343 by 108. So correct option is, so that is 7 cube by, correct option is 7 cube by 108 is 3 cube. 3 cube is 3 cube 27. Any other thing is given? I am getting the wrong answer. Let's check it again. Let's check it again. Calculate it. So it will be 7 cube upon 3 into 3 into 3. Right. 3 into 3 into 4. Yeah. So 7 cube by 3 cube into 4. So 4 is there any wrong thing we did? 6x 6x minus, let's check again. Guys, check it again. 6x minus 6x upon 7 square, right? So 6x 7 multiply हो जाएगा, तो it will be 42s minus 6x, right? So 36x upon 49 is equal to 7 by 3. Yes, clear? So 7 cube is equal to 36 into 3. So 36 into 3 will be 3 into 3 into 3 into 4. हाँ, सही तो है. Maybe answer में कुछ गलती होगा. Maybe there is some mistake in options. That is 7 by 3 whole cube into 1 by 4. This will be your, oh, sorry. In the question it is asking, what it is asking? Arey yaar. To find 4s, na? Sorry. To find 4s, in the question it is asking, find 4s. If s is this is s, right? This is my s. S I am getting 7 by 3 whole cube into 1 by 4. Then 4s will be, hence 4s will be 7 by 3 to the power 3. Oh, seriously, yaar. I did the mistake. Okay, so answer is, correct option is 7 by 3 whole cube. Option C is the correct one. Okay, option C is the correct one, guys. Okay, so what we did to solve this question? Let's see. First, we write the given series and we observe the denominator in GP and numerator को observe किए. फिर the method is multiply the common ratio with the given series and write below the given series. Writing by one step forward in the right hand side and then subtract the resultant new series from the given series And then what you are getting, now you can observe the all in the news, what you are getting the new series, all the numerators are in arithmetic progression and all the terms of the denominators are in geometric progression. Again, multiply the common ratio with the given with the new series what you got in previously. Then after multiplying 1 by 7 on both sides, similarly write the in the right hand side, write the resultant series stepping by forward one step. Okay, and then again subtract. After subtracting, you are getting an infinite GP in the right hand side, and apply the formula to find the sum of the infinite series. Then simplify and you will get the answer, that is 7 upon 3 whole to the power 3. Clear everyone? Chalo, ठीक है. Okay, so let's move to the next question. Method of difference or telescoping or VN series. So actually in arithmetic progression or arithmetic geometric progression, there are a lot of special type of questions. I suggest to go through all the type of questions and try to solve all the type of questions came in previous year JEE mains also, and learn how to attend which question. That is important, right? Actually, in sequences and series, questions are coming from the concept arithmetic geometric progression. Clear everyone? Okay. So come to the next question. Yeah. Yeah. So come to this question first. We'll learn this question because this is important. Here, see, it is given that summation n is equal to 1 to 2n, so 21, that is 21, c upon 4n minus 1 upon 4n plus 3. Okay, so you have heard about partial fraction. We'll use your partial fraction also, but not accurately partial fraction. In integration, you'll use partial fractions, integration by partial fraction. Okay, so we'll learn another method here, that is method of cancellation or difference, we can say. Okay, so let's see. So try to in such type to solve such type of equation, such type of question, try to bring the denominator in the numerator. Okay, try to bring the denominator, difference of denominator in the numerator. Okay, so if we are having two factors in denominator, one is 4n minus 1, one is 4n minus 1, another one is 4n plus 3. If we'll subtract 4n minus 1 minus 4n plus 3, so what we are getting? We are getting 4, right? Or 4n plus 3 minus 4n minus 1, if we'll do, we are getting 4, right? But in the numerator, we are having 3. So take this 3 to outside first. This will be problematic. N is equal to 1 to 21. Okay. And write 1 upon 4n minus 1 into 4n plus 3. Okay. So see, now what I am trying to do is I am multiplying by 4 and dividing by 4, because the difference of both the factors present in the denominator is 4. That's why I am multiplying 4 and dividing by 4. Now you can see the magic. 3 by 4, summation n is equal to 1 to 21. Can we write numerator as 4n plus 3 minus 4n minus 1 divided by 4n minus 1 into 4n plus 3. Can I write? Yes, we can write. Yes. Okay, now see, 3 by 4 summation n is equal to 1 to 21. Can I write this was 4n plus 3 divided by 4n minus 1 into 4n plus 3 minus 4n minus 1 divided by 4n minus 1 into 4n plus 3. See here. See here. 4n plus 3 and 4n, sorry. 4n plus 3, 4n plus 3, 4n minus 1, 4n minus 1. They are cancelling each other. So finally what we are having? We are having 3 upon 4 summation n is equal to 1 to 21, 1 upon 4n minus 1 minus 1 upon 4n plus 3. Clear? Clear, guys? Now we can see the magic. Okay, put n is equal to 1. Put n is equal to 1 here. So what we are getting? Put n is equal to 1 here, or open the summation, open the series. If I'll ask you to, if I'll suggest you to open the series, what you are getting? We are getting 3 by 4. If we'll put n is equal to 1, I'm getting 1 by, if we'll put n is equal to 1 by 4 into 1 minus 1, that is 3. 1 by 3 minus 1 by 4 into 1 plus 3, that is 1 by 7. If we'll put 1 by, if we'll n is equal to 2, I'm getting 1 by 4 into 2, 8 minus 1, 1 by 7 minus 1 by 4 into 2, that is 8 plus 3, 1 by 11 plus 1 by 11 minus 1 by 15 will get. Likewise, and lastly, we are getting, if we'll put n is equal to 21, I'm getting 1 by 21 into 4, that is 84 minus 1, 83 minus 1 upon, if we'll put 21 here, 84, 84 plus 3, 87. Guys, you can observe here, all these terms are cancelled out. 1 by 7, 1 by 7, 1 by 11, 1 by 11, 1 by 15 and 1 by 33. All these terms will be cancelled out each other. And finally, we will be having 3 by 4 into बचा भाई हुआ क्या है 1 by 3 minus 1 by 87. Now you can calculate 3 by 4, take the LCM, it will be giving you 87, 8 plus 7, okay, 87, that is 87, 29 minus 1, which is equal to 3 by 4 into 28 upon 87. So finally, the answer will be 21 upon 87. So correct answer is 21 upon 87. I hope this is clear too, and this is a very interesting method to solve this type of equations. Remember, when you are getting in examination like this type of questions, like you are having some factors in the denominator and nothing in the numerator, then you need to follow this cancellation method. It's a very interesting method. Cancellation method you can use, and you can find the code. How easily we can find the answer. How easily we can find the answer. I hope this is clear to all of you guys. Is there any doubt? Is there any doubt, guys? Is there any doubt? No? Chalo. Let's take this question as your homework question. This is also one type of two type of arithmetic geometric progression we have discussed. Okay, try this by your own. Type 3, how we can find the sum of this series up to n terms. Take a screenshot of this question and you can note down it also. Second thing, this is for your homework. Take a screenshot of this question. Okay, this is type 4. We don't have time, otherwise we'll discuss all the types. Okay, this is type 5. Okay, homework question. Try it by your home, or when you are getting time in school, when you are getting time in school, or when you are sitting in your lab, you can go through the Google or YouTube. You can search all these questions, how we can solve, what are the shortcuts, what are the methods to find the sum of all such type of series. Okay. Another question? No, no questions we are having. Thank you all. This is time to end here your class. Thank you all. Bye bye. Take care everyone. Chalo. ठीक है. It's time. Bye bye.